Next, we'll cover structured and coded data in FHIR resources. First, the HL7 FHIR vocabulary. This supports coded data of varying complexity. Some codes are defined as part of the FHIR resource. Others are referenced from external vocabularies, such as LOINC, SNOMED, and UCOM. The fact that some will differ by implementation space should be recognized, and the FHIR value set resource can be used to define complex code lists. Many such lists are stored in the U.S. National Library of Medicine's VSAC, or Value Set Access Center, and the FHIR vocabularies are managed by the HL7 Terminology Authority, a group in HL7. First, it's important that there are a number of different data types represented in the FHIR specification. These vary from simple data types, metadata types, and special purpose data types. They include identifiers, and each data element in each FHIR resource has a specified data type with which it is represented. This is part of enabling interoperability, is that not only the data element definition, but the data type used are both specified in the FHIR specification. The simplest of data types include the primitive data types, such as time, date, and text strings, integers, and binary representations of data, as well as a number of others. These are all based on the W3C schema of the World Wide Web and on ISO, International Standards Organization, data types. There are also complex data types, which are data types that are composed of other data types. These include such things as human names and postal addresses, as well as the coding of data for code systems, and a fairly often used data type referred to as codable concept, which implies that there are one or more code systems that can represent that data element, or it can be a text string if no code exists. It's also important to note that for these complex data types, some of them, such as human name and address, there are actually profiles specific to different jurisdictions, different countries. As you know, different countries, different cultures represent a human name differently, and certainly almost every country represents its postal addresses differently, so there need be profiles for those data types that are specific to those different countries or regions. So if we take a quick look at a representation of the condition resource and looking at the body site data element, you'll see in the middle column it says codable concept. That's the data type required for that data element. And if you look down to the other red circle around range, this is a data type for the onset range of a condition. So terminology and data types are both required to represent coded data in FHIR. In this case, the example is a LOINC code for pregnancy status, which includes the definition or description of this. An example of a value set, which is a collection of codes that may be required in a specific data element. This example is skin color, and there are a set of LOINC codes for skin color. These are assembled in this example into a value set ranging from normal to pale, flushed, red, all different descriptions of skin color that would be included in this value set, so that there is a limited number of descriptions that could be used in recording data. Otherwise, people might use slightly different words for what is intended to be the same concept, so we create value sets to enable consistency in representing a particular data element. Here's another example. where the value set is a way to specify the certainty about an observation or condition, ranging from known, proven, to suspected. The example here is breast cancer. So this diagram is a representation of how terminology is used in FHIR. So on the right, in the purple box, is an element definition for a particular element within a FHIR resource, and that element is bound to a certain value set. That value set is a selection of codes for use in this particular context for this data element. It might, as in this example, be a set of SNOMED CT fracture codes. Those then come from the code system represented on the left in the blue box that includes the code, the display text, and the definition of each code. Those are represented as an element instance with a coded data type and a specific member of that value set, in this case for fracture of the shaft of the ulna. In addition to the concept of value sets, an important aspect of terminology in FHIR is the binding strength. So a data element is bound to a particular value set, and the strength of that binding varies from required, meaning you must use that value set and cannot select codes outside of it, to extensible, meaning you are given a set of codes but you can add to that value set, or preferred, where there are codes provided but you might choose an alternative code, or example binding, where a example value set that is limited is provided. So an example of terminology binding would be value set for birth sex in an HL7 FHIR resource, where the strength of the binding is required and the description of that data element is the code for sex assigned at birth.